This is your host, Abhinav Bhartiya, and welcome to a brand new episode of TFiR Let's Talk. And once again, we have with us Harry Aujla, EMEA Pre-Sales Director of SIOS Technology Corp. Harry, it's great to have you back on the show.
Great to speak with you again, Swap.
Yeah, and today we are going to talk about high availability for telecom sector. I want to know from you how different are the IT needs of the telecom sector than other industries.
When we think about the telecom sector, it's one that's actually quite unique because it's one of those sectors that has a direct impact on most aspects of our professional and our personal lives on a daily basis. It somewhat sort of goes without saying that businesses and individuals around the world rely heavily on the ability to connect and communicate with each other. In today's interconnected world, the disruption of things like critical comm services, even if it's just for a few moments, can result in millions of dollars of lost revenue and also potential damage to customer relationships. And it's also safe to say that telecoms is one of those core components of a wider critical infrastructure picture, which also includes energy, water, and transportation. So it makes it one of those cornerstones of today's societal requirements. So in order to sort of keep up with changing demand, the sector is one of those sectors that is continually growing and evolving in terms of technical innovation and delivery scale, which is largely driven by developments associated with aspects such as 5G rollouts, the increasing reliance on cloud computing, and the association that cloud computing then has on further aspects such as the Internet of Things. So maintaining uptime and availability of both customer-facing systems and back-end systems is becoming increasingly critical. Many of these organizations have recently assumed the role of managed service providers in the context of convergence between voice and data services. So aspects such as agility and reliability, they become really key as telcos are constantly trying to keep ahead of the curve to ensure that they can meet that demand. So with all that in mind, the role of the traditional telco as we used to know it has changed significantly over the past number of years. There's a heavier reliance on software-defined systems and also a move towards decentralizing many functions as well through increased cloud computing usage. So with this comes the need for maximizing uptime and meeting availability service level agreements. Although software-defined systems, they solve a lot of problems, but they can also introduce additional complexity as well. So highlighting the need for fault tolerance or high availability around these systems becomes even more important. Cloud computing, as we know, it delivers good high availability, but it's largely for the cloud platform itself. It doesn't really focus beyond the physical or OS layers of the solution stack. So there's some further thinking required around how solutions can be architected and how they can be deployed to help meet those stringent SLAs.
How critical is the IT systems continuity for telecom players?
It sort of somewhat goes without saying, Swap, that IT continuity in this sector is, let's face it, it's going to be super critical. And this can be seen sort of in the types of systems that these organizations need to rely on, which can vary. At one end of the scale, there are what we would say infrastructure critical systems, such as the physical copper and fiber networks, the internet networks, and the cellular and mobile networks. Those core public infrastructure networks. And these are typically protected with a fault tolerant solution, or in other words, a solution that delivers 5 nines of availability uptime. And when we say 5 nines, we're talking about no more than 5 minutes of downtime in 1 year. And that's pretty much the highest level of availability protection that you could apply. FT systems, as we call them, they're generally used only for the most critical applications because they do introduce significant cost and complexity. and they generally tend to rely heavily on vendor-specific hardware platforms. So they're not generally built for cloud platforms. And because of that, they're not really the appropriate solution for all types of systems, apps, and databases that the telco might be running. But there are many other systems that are best protected with high availability solutions instead of FT solutions. And high availability solutions are designed and geared towards delivering 4 nines of application uptime. Now, these types of systems, they're typically going to deal with aspects of telecom such as service configuration, order fulfillment, customer care, billing, and other types of services and offerings as well, such as voice over IP or VoIP systems. And for these essential systems, the SLAs delivered by high availability solutions rather than FT solutions, they're going to be more appropriate and generally more cost effective to apply. So when we think about these things, it opens up the opportunity for choice and flexibility as to how these solutions are deployed and where they're deployed. So for example, can we deploy these solutions on cloud platforms while still delivering an SLA of 4 nines?
As you talked about it earlier, that telcos are embracing virtualization. It is becoming software defined. They are embracing cloud technologies. Can you talk about, when we look at modern telco infrastructure, which is mostly software defined, how does that affect the IT system continuity?
If you think about the impact of an increased number of software defined systems, it's quite a significant impact because it's allowed telcos to embrace that digital transformation into the cloud. Telcos are beginning to leverage the cost and flexibility benefits that cloud computing presents. And these benefits allow them to deliver new products, new services, and new innovations to their customers at a much lower cost and in a much more agile and responsive way. So one example is, and I mentioned it slightly earlier on, is voice over IP or VoIP systems. If we think about it, in the good old days, we used to rely on traditional telco switches for our telephony backbone. And it's these types of systems that have been largely replaced by VoIP systems, which are now just as critical. So at a basic level, a VoIP system is usually a software-defined solution that is a fully featured state-of-the-art telephone system. And the brains of the system will generally run on a central server, which becomes a single point of failure in the architecture. Very simply, if the central server fails, the VoIP network goes down. So providing high availability for the central server, again, becomes super critical. And VoIP services differ because they can either be delivered as a hosted service from a vendor, where the vendor is responsible for providing high availability, or they can be off-the-shelf products that customers can deploy and manage themselves, which will require them to make their own high availability arrangements. And we're seeing more of these types of applications being hosted in the cloud. But when you're running these services on the cloud platform provider will only provide high availability services to a certain level within the solution stack. And this usually stops at the level of the cloud infrastructure itself, where a 4 nines SLA is supplied for the core cloud components, such as the cloud instances, the storage, the networking, etc. That 4 nines SLA doesn't extend to your VoIP application and its associated database running within the cloud instance. So, for example, let's say a cloud instance fails for whatever reason, then the cloud high availability tools, they're going to facilitate a recovery to another cloud instance. And that's fine, that's great. However, if the VoIP application or its database suffers an application fault, yet the cloud instance is still running, then the cloud high availability tools are not going to react. So for VoIP providers and VoIP customers, they're going to need to think about maintaining their required SLAs within the cloud instance. And this is generally addressed by deploying third-party high availability tools and solutions, such as SIOS, specifically designed for delivering 4 nines of availability at an application and a database level. So this type of thinking, that's not just around VoIP. That kind of thinking can be extended to further systems that a telco could be running. So let's take another example. Let's talk about a billing system, which again is a really critical system for a telco. Now, to the average customer, a billing system is a billing system. But to the telco, the billing system is in some cases a fundamental self-service portal where businesses and consumer customers can view their billing and arrange their payments. Now, if the billing systems are unavailable, very simply, the customers can't view their bills and neither can they pay them. So that's going to cause disruption for all parties involved. And this could impact revenue and equally as importantly, customer satisfaction. So these are exactly the types of areas where solutions from SIOS can fit in. Our aim at SIOS is to deliver application availability, SLAs, of 4 nines, no matter what the underlying infrastructure looks like, regardless of application and regardless of database. So, for example, you might have a billing system that's entrenched within a sophisticated SAP landscape, and you could be running that on an SAP HANA database, for example. Now, both the billing app and the HANA database will need to maintain an agreed SLA, which could be upheld by our SIOS Lifekeeper for Linux solution. Additionally, you might have your billing system running on a Windows platform where the database could be SQL Server. And again, SIOS has the appropriate tool set to maximize uptime in these environments using our Datakeeper Cluster Edition solution, which is designed to integrate with Windows failover clustering.
Earlier, you were talking about IoT and Edge, which is, when we do talk about telco, we do talk about Edge, we do talk about it. It's kind of a continuum of the cloud, continuum of the networking. That's what it is. So talk a bit about, once again, the importance of high availability in Edge and IoT space.
Yeah, absolutely. Yeah, we've talked about telcos and the kind of applications that they run and the range of applications and services that they deliver. So they need to consider that cost to SLA benefit when they're thinking about high availability around these types of solutions. And like you've mentioned there, Swap, one of the most prominent areas where we see this being deployed is around IoT, which again is one of those areas where telcos are embracing the benefits of cloud computing. And when we think of IoT, we think about an expansive and sprawling network of data capture devices constantly feeding data back into some sort of central brain. And the central brain is usually an application running on a Windows or a Linux-based server. Common examples of IoT networks include things like environmental sensor networks, tracking and monitoring, smart cities, smart homes, and so much more. And the sheer amount of data that these systems are collecting is mind-boggling. So it makes sense to leverage the flexibility and agility that cloud platforms can deliver in terms of their abilities to process transactions and data queries. And let's face it, clouds are predominantly built to manage large amounts of data. So we want to make sure we leverage those platforms. Now, the endpoints of these IoT systems don't typically need high availability. Things like cameras, thermal sensors, or whatever devices you're using to collect the data. It's the data itself that's the critical piece. So with the increasing amount of data being collected, this places further pressure on the underlying infrastructure in terms of servers, storage, and networking. So this is driving the increased need for cloud consumption and edge computing, which again needs to be reliable and needs to be available. So for example, where high availability is necessary is at that central server point again and with its associated databases. These can become single points of failure in an IoT network. So suppose the controlling application goes down or its database fails. In that case, there's no instant backup for either the application or the database, resulting in services being brought to a stop. And if we think about a scenario of, let's say, the heating and ventilation or fire protection systems in a hospital, and those systems experiencing an outage, that kind of failure could be catastrophic. So that's where high availability solutions such as SIOS come into play in an IoT environment.
We talk about that telcos are moving to software-defined cloud-native technologies. Can you talk a bit about what unique challenges does that pose when it comes to application availability, protection, and if you can also talk about how players like SIOS help them?
So again, if we take those previous examples, we talked about VoIP and we talked about IoT, providing high availability for that central server application and its associated data is what the real critical piece is. Cloud providers, they're going to offer some products and some techniques for building HA systems around those applications and databases. But their high availability solutions, like we mentioned earlier, are more geared towards availability of the cloud infrastructure itself. Cloud providers who highlight 4 nines availability, what they're doing is they're drawing towards the cloud components, such as the cloud instances, the networking components, and the storage pieces. So in other words, they're referring to availability of the cloud. Their technology, however, is not going to monitor what's happening inside the cloud instance where your IoT-centric application could be running. If the application fails, but the cloud instance is still running, the cloud-based high availability solutions, they're not really going to react to that. So customers, they need to take responsibility of the application availability in the cloud. And they're going to need to consider an application-centric high availability solution. And again, this is where SIOS fits in. SIOS has the ability to cluster and monitor the application and the database. And should it detect any failures, it can fail over the application and the database to the next available node in the cluster. And that can happen within minutes. It can even happen within seconds, depending upon the kind of infrastructure that you're running. So what this does is this vastly improves the overall high availability SLA for the protected application compared to using the cloud high availability tools alone, where their recovery strategy is just simply based on rebooting an entire instance.
So once again, thanks for explaining that. But I want to go a bit kind of in detail, deeper. So if you can also talk about what kind of application protection they need in the cloud, and once again, what kind of solutions are there for them?
Be it a telecoms networks, be it sort of software-defined telecoms applications such as VoIP, billing, etc., or an IoT network, as we've discussed, the critical need for application, data, and network availability, that plays a really large part in identifying the availability SLAs required for these components. And that then dictates the type of solution that you actually need, the type of solution that you need to roll out. So as previously mentioned, for the most supercritical of availability requirements, the consideration for the type of solution generally starts at a fault tolerance solution level, an FT solution. But more applications, what's happening is they're falling into the category of quote unquote essential services than ever before. And the cost and complexity of using FT solutions across the board, this pretty much rules them out in many cases. So if you're going to go up the road of considering FT solutions, you have to be prepared to invest heavily in these types of solutions. Alternatively, HA solutions tend to be the go-to type solution for most classes of applications in this sector, largely due to their cost to SLA ratio. HA solutions like SIOS Lifekeeper and SIOS Datakeeper, they have application-specific intelligence built in and are more flexible and can be deployed in a wider variety of platforms, including physical servers, virtual servers, and cloud platforms. So they're also more digestible in terms of price the guaranteed SLA is 4 nines, which guarantees no more than approximately 50 minutes of unplanned downtime in a year. So this becomes more acceptable in terms of a compromise to make sure that we're weighing up the associated costs of the solution and also thinking about implementing whether we're running high availability over FT. So SIOS have been experts in the high availability market for 20 years. We specialize in availability requirements of the core applications and the core databases that run at the heart of these critical infrastructures. Our solutions are agnostic and they can deliver standardized high availability experiences across a complete infrastructure.
Harry, once again, thank you so much for taking time out today and talk about the, once again, criticality of the telecom sector. Their challenges are different and unique from a lot of other industries. So thanks for sharing not only those challenges, but also how company like SIOS help them, and also sharing all those insights that you have. And as usual, I would love to have you back on the show. Thank you.
Thank you, Swap. That was great. Good to speak with you again.